Hello, everyone. I'm really excited to be with you today. My name is Omar. I lead the Artificial Intelligence and Machine Learning practice in Esri. And I want to speak with you today about AI and ArcGIS. AI is no more hype. It's applied literally everywhere. It's happening with self-driving cars. I see these a lot in California, where I come from. It's used to predict crimes by analyzing historical crimes data. It's used to predict stocks in the stock market. Predictive maintenance to predict the failures in machines. A lot of oil and gas companies are using this today. Sentiment analysis, chatbots, personalized marketing, facial recognition, advanced video analytics, and even this robot in the upper right. And I want to speak with you today quickly about what's AI, what's machine learning, what's deep learning, before jumping into what we are doing with it today. We look at artificial intelligence as the idea of having machines achieving human-level intelligence. And this has multiple categories under it: reasoning, natural language processing, knowledge representation, and machine learning. Machine learning is a field of AI that's about learning from data to extract rules and derive patterns instead of being explicitly programmed. And deep learning is a subfield of machine learning using a specific technique called deep neural networks that is really very good with high-dimensional data, like voice, images, and text. So in summary, we look at it that way. AI is the big umbrella, machine learning as a subfield of AI, and deep learning as one category out of that. And maybe you're asking yourself, what does this have to do with ArcGIS and my work in 2018 and 19? We have machine learning tools in ArcGIS that we have been building for years. And these range from prediction, clustering, and classification tools. You can use the machine learning tools in ArcGIS to make predictions, find interesting subsets in the data using clustering, and even make classifications in imagery. And I want to show you some quick demos for those. These are 35,000 accidents that we got from the Department of Transportation. And these are fatal accidents. And as you can see, they are literally everywhere. Even if you zoom in and zoom out, you cannot really see any kind of patterns, right? One of the tools that can help you find patterns quickly is clustering. And one of the techniques that we have is called density-based clustering. It's finding interesting, statistically significant clusters in the data based on their spatial proximity. And when we apply density-based clustering to this data, it highlights the top 67 clusters that are significant in these fatal accidents. So we can quickly understand where are the different areas that we need to focus on. We need to make some action to prevent those kind of fatal accidents. Now, by doing more analysis and applying more filtering, we can start seeing where are those homogeneous clusters that are caused by one reason of accidents, say a car hitting a pedestrian or a car hitting a tree. And these are the homogeneous clusters that are caused by this one reason. And by zooming into some of those, we can start revealing patterns that was very hard to reveal out of this massive data that we have seen. These are 3 fatal accidents that happened on highway in front of a truck stop. And as you can see, there are no traffic lights here. So maybe if the Department of Transportation communicated this intel to the state agency and have more traffic stops here or lights, it might save more lives. So this is a quick example of the machine learning tools that we have today in ArcGIS. And in fact, we have a lot of these tools, not only the techniques that we have just seen. So we have prediction tools, classification tools, clustering tools. And these are using machine learning without the need to write any piece of code. And I really invite you to play with those tools if you haven't already, because they are extremely valuable. In addition to that, we provide the ability to integrate with machine learning and deep learning frameworks, like IBM Watson, Azure Machine Learning, Scikit-learn, TensorFlow, PyTorch, you name it. And we provide those integrations by APIs. For example, we have the ArcGIS API for Python that can integrate with Python-based frameworks, and the R bridge that can integrate with R. So what about seeing some examples of those? Talking about accidents, it's taking away the lives of the people that we love. So can we use machine learning with ArcGIS to predict where accidents are going to happen and see how can we prevent them? So when we thought about this, we tried to understand what are the factors leading to road crashes. And there are a ton of those. Maybe weather aspects, like temperature, wind speed, visibility, snow depth, maybe temporal aspects like time of the day or day of the week, maybe spatial aspects like the road length, or the number of lanes in the road, or the degree of road curvature, or the speed limit, or the sun direction. We have tens of variables, and we have got some data, about 7 years' worth of data, 400,000 accidents, 500,000 segments, public data available for Utah. It's nearly impossible for any human to analyze these manually and figure out where accidents are going to happen, but we think machine learning has a shot for that. And for this, we have used ArcGIS with machine learning to predict where accidents are going to happen. First, we start by collecting this data. We got the historical accidents data, road network layer, the average daily traffic, the signalized and non-signalized intersections, weather from 27 weather feeds, and we started calculating some spatial attributes. Like, for example, you can think of this figure. Many accidents are happening near intersections, right? So maybe proximity to intersections is one factor. The road curvature is another, and the proximity to billboards. And we have used the Python API to load this data into a Jupyter notebook and started using machine learning to train a model. This is the training data set that we have used using ArcGIS. And for every accident, we have about 130 variables that we have used to train a model to predict where accidents are going to happen. And this is the result. This is December 3rd at 3 p.m., and the color here represents the risk of the accidents. The red and the orange are the most risky, and the green are less risky. So when we have seen the actual accidents that happened at this hour, that was the result. And you can see that most of these accidents are happening on those roads that we have predicted already, right? Now we are envisioning some applications. Maybe we can use the location allocation service to optimize the allocation of highway patrols to reach faster. Or maybe we can design an app that takes you through the safest route. So that was a quick example of how we have used ArcGIS with machine learning to predict road accidents. Now, this is only one example. We have a lot of other examples. And maybe we want to talk about deep learning. We have mentioned at the beginning that deep learning is becoming extremely powerful in computer vision. So we have used this in detecting some interesting things related to transportation. Here we are detecting different kinds of cars or vehicles, like cars, buses, motorcycles, pedestrians, in real time using convolutional neural networks, which is a technique of deep learning. And through the Python API, we are integrating with operations dashboard to understand where are those objects happening in real time. These feeds are coming from CCTV cameras, and we want to understand some traffic patterns out there. So not only we can detect this in real time and visualize it, but we can take this one step further by storing the historical data and starting to see some analysis. So if we have a look at the operations dashboard here, this is taking feeds from 111 cameras in Washington, D.C., and helping us using deep learning and ArcGIS understand the traffic patterns across the whole city. You can see the number of detected cars, pedestrians, buses, everything. You can even go to specific intersections and start analyzing what's exactly happening. One thing that we have done is storing this data to start seeing the abnormal events or the abnormalities. Like, for example, here, we can select a specific kind of activity, like buses or trucks or cars, and start seeing where are the abnormal events. Like, for example, this red part here. And if we click here, we're going to see that we have an abnormal amount of buses. And we can even apply the same thing for cars to see where are the high amounts of cars compared to the history. So you can click here and go to the feed and start seeing those cars in real time. So that was a quick example of using deep learning with ArcGIS to analyze traffic patterns. And maybe we move on to some more commercial applications. We deal with a lot of retailers and banks who are interested to use deep learning and machine learning to predict the best area to open a new store, or to predict the best area to launch marketing campaigns. And when you think about it, it's really interesting, because we have very interesting data set if you're using ArcGIS that can help you with this. So let's have a look at that. In the data that we have in the US, and we have a lot of similar data here in Spain as well, we have demographics, consumer spending, traffic counts, crime index, tapestry segmentation, a lot of demographical data about the age, gender, income levels, etc. And we have been using this data in a lot of applications. For example, business analysts that we're going to talk about today. And people have been manually adding some of those variables to try to find the best area to open a store or to make a promotional campaign. But if you think about it, no human on earth can figure out what are the factors that are exactly affecting their sales performance. It's really hard when we are talking about thousands and thousands of variables, right? So the idea that we have, what about using those demographical data along with the customer's data, like sales, for example, or competitors or wholesalers, and use AI to predict events of interest? And that's what we've done here. So we have worked with some of our customers to predict the boost or the increase in online sales based on the physical store location. So they want to understand, where should we establish physical stores that would have the highest expected sales, not only physical ones, but online as well? And for that, actually, we got a lot of historical data. So we got data regarding, for the last 3 years, we got physical store sales, online sales, competitor location, wholesaler location, and starting adding these data together. So we got the data about all of the physical stores, and we got the data about all of the wholesalers, and as you can see, there are a lot. We kept throwing in more data, like the location of the competitors, and we started deriving some spatial attributes, and this is really important. The edge that we have in our platform is the idea of having spatial. And we wanted to understand the effect of having a store at some area, like this, on the surrounding areas. So we wanted to measure the proximity to that store. Given that we have the sales, online sales, for every one of these zip codes, and we have the store location, we want to see, is there a relation between the sales at this zip code and being near or far from this store or not? So first, we started by measuring this distance using Euclidean distance, straight lines. But our model's performance wasn't that great. And you can think about it, it's logical, right? Because people don't travel in straight lines. They travel in roads, basically. So we changed that to the drive time. And we added the driving distance as a factor. So now, again, we use the Python API to load all of this data here. We added, for every month, for every category, the physical store sales, the online sales, the location of the competitors, how many competitors, how many wholesalers per zip code, and a lot of demographical data. Consumer spending, the time people spend online, the last time they visited Amazon or Facebook, age, gender, income levels, you name it. So we have about 1,767 variables for every zip code, for every category, plus the sales amount. And as you can see, it's crazy here. And we started training a model to predict the top areas in the US that if this customer opened a physical store, they're going to have the highest amount of sales. And that was the result. The machine learning model in that case had about 94% accuracy. We used a machine learning model called gradient boosting. This map is highlighting the top areas in the US with expected sales from about $600,000 to $1 million boost in online sales. And the color reflects that. We can see that the East Coast has a lot of potential. And we can see that those red areas, actually in Baltimore, in Philadelphia, and in some other cities and countries, can have huge potential as well. So can you think about the potential of that? If you are a retailer or a bank, and you have a lot of historical sales data, if you add this to our data and start using machine learning, you can have something like that. You can understand where are the best areas that would affect your business the most. Another interesting example that I want to show to you is related to logistics and supply chain. So we deal with many customers who have large number of fleet or trucks, right? And they want to predict accurately when these trucks are going to arrive to their destinations. And when you think about it, you can use our product called Network Analyst to answer this question, right? But if you want to do this really fast, if you want to click on a dot on a map, drop a pin, and know what is the reachability, how much time is it going to take people coming from thousands of locations to this location quickly? So we trained a deep neural network model to do this kind of prediction of arrival times very fast. And let me show you how this works. refresh that to ensure you have a recent version. So the idea of this actually is to do this really fast. And this application is used the deep neural network to predict the arrival times. And we want to click, like what we have clicked here, and quickly understand under 1 second how much time is it going to take people to come from all of those places into this store location, for example. The output is produced as a continuous raster, as you can see. And the legend here highlights the arrival time. This is the time it's going to take people to arrive from different locations to this location, and starting from 5 minutes up to 60 minutes. And maybe if you are a bank or a retailer or a supply chain and you want to choose the perfect spot, or even a public safety agency who wants to place their strategic assets wisely, like, for example, ambulance cars, and you want to predict this kind of arrival time very fast, you want to choose those locations dynamically. So maybe you see that this area, for example, people are going to arrive in like 40 minutes, so this is too long. So we can drop another pin here, for example. And boom, it's going to calculate this under 1 second. And you can keep on doing this, right? Adding more and more locations. And just to give you a sense of how much calculations are happening here, these are the arrival times from all of those small dots to these big dots here. And those calculations actually are not happening in like 1 hour or days. They are literally happening very quickly. Like, for example, here we have 6,773 calculations under 0.19 seconds. And by throwing in demographical data that we have in our software, you can see the breakdown of the kind of people who are reachable. One other application of this is to predict the arrival of vehicles or customers. So this dashboard actually is showing if you are a coffee shop and, for example, people are ordering coffee from a mobile app, you want to predict exactly when they are going to arrive to the stores, right? Or if you're a logistical provider, you can predict exactly when these vehicles are going to arrive. So the color represents the time it's going to take this person or this vehicle or this customer to arrive to those stores. And as you can see, this is happening in real time. So we can visualize how many customers are going to arrive to your store under 5 minutes, 10 minutes, 15. And if you're a coffee shop and you want those customers to really reach fast and get their coffee, which is hot, you can subtract the amount of time it's going to take the order from the arrival time and know exactly how many orders are late or on time or early. Isn't this the cool? Thank you. Thank you. Another example that we have worked on with some utilities, they want to detect broken insulators. What you're seeing on the screen here is a broken insulator on the lower left. So you want to check about the assets of your health, the health of your assets. So they fly a lot of drones, they capture images, and they had people manually watching these images from drones to try to understand where are the broken insulators and send inspectors. But if you think about it, this could be automated using deep learning, right? We can train a model to recognize this, and that's exactly what we have done here. So we got a lot of data that they have stored, which was labeled, actually, and start to train a deep learning model using IBM Watson to understand which insulators are broken or not. And this is happening in real time. The drone is flying, and whenever it detects a broken insulator, it's going to detect that and have this kind of red circle here, which is going to tell the analyst that, hey, something is wrong here, you guys need to take action. Another example in the area of road and infrastructure, there are millions and billions of dollars being spent on fixing the infrastructure. And if we have an easy way and a cost-effective way to detect the road cracks, it's going to be a lot helpful. So that's what we have done here. We got a public data set for road cracks, different kind of road cracks, like the longitudinal cracks or the crocodile cracks that you can see on the top right, and different other types of cracks. And this deep learning model is able to detect those cracks whenever it sees them. And what you're seeing here is a video for someone driving around the Chesapeake area, and the deep learning model is detecting in real time those cracks and storing them by location and time. And when you start thinking about the possibility of adding this to ArcGIS, you can see something beautiful like this. This is visualizing the amount of cracks per road segment And then you can see this on the map, you can see it on the chart. And as a transportation authority or a traffic authority, you can start leveraging this super low-cost technique to prioritize your resource allocation. Now, maybe you are asking yourself, is this really hard to do? Can I do it? Do I need a PhD in deep learning or whatever? And the answer is not necessarily. There are some really great techniques that you can leverage without writing any piece of code. And in fact, I personally believe that the way to make AI powerful is by democratizing it and enable a lot of access to many people. So for this, I really invite you to try the Custom Vision Surface by Microsoft. So if you go to customvision.ai, Microsoft has developed a cognitive service called Custom Vision Service that is using deep learning under the hood and enable you to do this kind of deep learning without writing any code. So one of the customers that we have worked with, they had tens of thousands of photos that they have collected for street view images for the houses, and they wanted to understand which houses has blight or graffiti or overgrowth or basically need some sort of intrusion or detection. And they were doing this manually. They were outsourcing a lot of work to their citizens to label each house, whether it has blight or not. They were doing it themselves, and it was taking ages to do that. Now, what about doing this using deep learning or automating? Can we save them a lot of time? And the answer is yes. So we went to the Custom Vision Service and started training a deep learning model. And the way this works actually is you just upload a bunch of data, not necessarily huge, for labeled houses. For example, here, we have a lot of houses that has overgrowth. So as you can see, obviously, this house has overgrowth of trees and some plants. That's the image of another house. So this is called a positive example. You need to apply this by having some negative examples as well. So we uploaded some photos with negative examples. And we trained the model. You just click train, and it's going to train. No code here. You can explore the performance and see the precision and recall, which gives you an idea about the accuracy of the model. It's generally about 80%. And you can easily connect this to ArcGIS. So our first AI solution in Esri is called Property Condition Assessment. If you Google this right now, you're going to find the link that takes you to this solution. You can download it. And if you have a trained model on Custom Vision Service, you can easily link it back to ArcGIS. And this is the result. So the solution that you're going to download has two fields, the Custom Vision API key and the Custom Vision API prediction key. These keys are provided by the model trained on Custom Vision Service on the cloud. So we can upload these items by having the values from Custom Vision uploaded here and start configuring this to run in Pro. And you can have this beautiful dashboard where it's automating the process of detecting these features for 180,000 houses in a couple of hours. You can see which houses has blight, which has graffiti, which has overgrowth. You can see the probability score. You can click on any of those houses and see the actual image to validate yourself. Isn't this beautiful? The idea of cutting massive amount of time and effort using AI and ArcGIS is just amazing. I personally like it a lot. And not only you can visualize this, you can do some analysis on top. What if you want to find those areas who have the highest concentration of blight or graffiti? You want to prioritize your resource allocation, for example. You can do a heat map like this, where you can see where this is happening. Finally, I want to share with you something. We have a joint offering with Microsoft called the Geo Ai Virtual Machine. This is a virtual machine on Azure that you can go and configure really easy. And it has ArcGIS Pro and AI components, open source and of Microsoft. So no need to install TensorFlow and scikit-learn and have a complex environment. Literally in a couple of minutes, you can have this machine on the cloud with all the components that you need to develop these powerful scenarios. Thank you so much.